Good morning.
Good morning.
All right. Yeah, could someone in Holbrook fix the camera? And actually, Joseph City, your camera needs kind of adjusted a little bit too. There we go. Let's a little better. Okay. All right. So let's see what we've got here. All right. I guess I'll just go ahead and call the roll here today. Andres?
Here.
Desiree?
Here.
Naomi?
Here. Can you tell me which direction to
Oh.
right, left, up or down?
Wait.
Raylan?
Go to the. Not here. To the right.
Caitlin?
Okay, that's too much. Go back the other way.
Tap it.
Caitlin's not here.
Okay. Avery?
He's
Cyrus?
at school,
I
but
thought
he's late.
He's
Yeah,
coming.
let's go.
Were they like that?
Okay, Cyrus is not there.
No.
And Avery is here. Okay.
Hopefully it works.
All right, Tara?
Here.
Tara?
Here.
Jay?
Here.
Lauren?
Here.
Taylor?
Here.
Ricky?
He's here. It's not in the hallway.
Seth?
Here.
Madison?
She's not here.
Okay. Kinsley?
Here.
Sierra?
Here.
Hannah?
Here.
Jocelyn?
She's not here. Not here.
Cottrell?
Not here.
Rebecca?
Here.
Jill?
She's not here.
Okay, Serena?
Here.
Anna Marie?
Not here.
All right, thank you. All right, so let's see. So a couple things before we get started. Anyway, I enjoyed having you guys up here yesterday. That was fun. I was thinking all morning. I kind of wish I could. Some days like today, I would just like to have a classroom of students like the old days and just teach, because technology has been my foe this morning because the Moodle actually, so I stayed like an hour after my last class, my evening class, to set up all the quizzes. All of that got wiped out, but that wasn't bad enough. My afternoon Math 152 class was completely wiped out. All the students, all their grades, everything. And so, anyway, so if you guys that had some hardships this morning, those guys that we've been working all morning restoring that class. And so it's just been a nightmare. So sometimes when you upgrade their system, that actually makes it worse. I'm just ready to throw out computers and it's just crazy. But I did, I said I was going to look at that chapter 1 test for several of you. And I know that the people that have told me I'm in the process. But if you haven't looked over chapter 1, if you made any other marks other than A, B, C, or D, it automatically counted it wrong. So you might want to just go through and then shoot me an email if you think you should get some points. And so there's a couple of you that have, so that's what I'm working on today. So I'm kind of in the middle of that. But send me an email if you think you might have done that, and I'll review your test. So, okay. All right. So let's see. Any other questions, comments, concerns before we get started today?
Yesterday was awesome. Thank you.
Oh, yeah. I was thinking, no wonder all the Holbrook people, we were missing so many, is that I'm not feeding you today. So I guess I learned that's a way to get you there is feed you. But I realized as I was talking to somebody yesterday is that was the first time in all my years of teaching that I've ever bought pizzas for all my students. So that you guys, I hope you can, you feel, you feel honored, because I was sure happy to do it. That was fun. It's kind of weird how it all worked out, but anyway, okay. And then before I forget, so let's see. So tomorrow we are going to be taking assuming the Moodle is working. Our quizzes tomorrow are 2.3, 2.2, 2.3, and 2.4. Okay. Now, I already opened those up last Friday for Holbrook. So if you guys have already taken them, if you took them on Friday, then you don't have to come in tomorrow. Okay. If you didn't take them, then anyway, you gotta do it then. So anyway, so 2.2, 2.3, and 2.4. All right. Now today what are we doing? We are working on 3. We just have a little bit to finish up on 3.1, and then we're going to go on to 3.2. Okay. Okay. All right. So let's go ahead and share this. So we're right there on 3.1. So that is on the back side, first column, about halfway down. Okay. Okay, so it says to write a function in function notation, you solve for y and then replace the y with f of x. So, for example, if we want to put this in function notation, you solve for y by adding 5 to each side and then replace the y with f of x. So that's function notation. So then if you wanted to say find the f of -3, that just means plug in -3 for x and then work it out and then simplify. Okay. All right, so go ahead and do practice 3B, please. Go ahead and do both parts. Okay, so Hannah, what did you get for the first part?
I got negative 17 over 2.
Negative 17 over 2 is correct. Okay, so in function form is f of x equals 7 halves x plus 2. And then when you plug in negative 3, you get negative 17 halves, or negative 8.5. Any questions on that? Anybody need me to go through it? All right.
Yeah, can you go through that, please?
Sure. Okay, so here to get y by itself, you add 1. And then, okay. Actually, you know what? Let's just start all over. I'm not sure I like this. Okay, so you can have the y on either side. So here I would add 1 and get 7x plus 4 equals 2y. And then divide everything by 2. And so you get y equals 7 halves x plus 4 divided by 2 is 2. And of course, you can put the y, you can switch sides. That doesn't matter. And then replace your y with f of x. So that's the function notation. All right, then when you plug in negative 3 for x, you get negative 21 halves plus 2. So negative 21 halves plus 4 halves is negative 17 halves. Okay? Now, if fractions particularly vex you, then how I would suggest you do it, just so you don't make mistakes with the fractions, is just store negative 3 in for x in your calculator, and then just type in 7 halves x plus 2, and then let your calculator do the work. Okay? So do that if you're having problems with the fractions. Okay? So any other questions on the first one? All right, well, let's go to the second one then. All right, Taylor.
Is the answer -2?
Is the answer -2? That would be correct. Good job. Now the function, if you want to check at that point to see if you got the functional form, would be the f of x equals square root of 1 minus x over 2, subtract 3, and then when you plug in -3 and work it out, you get -2. Okay? Any questions on that? Anyone like me to work that through? All right. Well, good job. Okay, so the variable that is used in defining a given function is called its argument. So in the f of x, the stuff here in parentheses, that's the argument of the function. Now, if we have like a trig function, like next semester, like cosine x, x would be the argument. Or if I have the g of x plus h, the x plus h is the argument. So if there's parentheses, it's whatever's in parentheses then. Okay. All right. So let's see if you can do practice 3C. And let's do all three of those parts because I did examples like that on Thursday. So let's see if you can do the f of a, the f of x plus h, and then the difference quotient on the top of the next column. All right, so Naomi, what's the f of a?
Is it the a squared plus 5?
Yep, that's it. You just swap out the variables. So instead of x squared plus 5, it's a squared plus 5. Okay? All right, so Sierra, how about the f of x plus h?
Squared plus 2xh plus h squared plus 5.
I think that's it. X squared plus 2xh plus h squared plus 5. Okay? So, yeah, I kind of wanted to check that before you got too far in part C or part 3 because you have to use that answer for the first part, the difference quotient. Okay, so any questions on that? All right, so I'll give you another little minute to work on part 3. Okay, so let's see what we've got here. All right, Rebecca. So just tell me your final answer on this one, and we'll see. Go from there.
H squared plus 2xh plus 10 over h.
Okay, so you have your so here's your f of x plus h minus your f of x all over h. Okay. Then when you drop the parentheses, you distribute the negative. And then your x squares cancel and your 5s cancel. All right. Now, so I think, isn't this what you said right here, Rebecca? Is that what you said? Something similar to that.
Yeah, I just had a plus 10 on the end, but I see what
Oh, okay. Oh, yeah. So you distribute the negative, so that's got to cancel. Okay. And then, so here's how you know that you did it right, is that if you can factor out an h and cancel it, the h's should always cancel on these type problems. So then your final answer should be just 2x plus h. So where you made a mistake with the sign and you ended up with the plus 10, then the h didn't cancel. And so whenever you're doing those type problems, that should be a clue to you to go back and double check, because the h's should cancel every time in the denominator. Okay. All right. So any other questions on that one? Okay. Okay. Well, I guess my technology woes are going to continue here today. So I seem to have lost control at the board. All right. Okay. Next, we want to talk about the implied domain. The implied domain of a function defined by an algebraic expression is what input values are allowed. In general, the domain of the function excludes values that cause either of the following to occur: zeros in the denominator or even roots of negative numbers. All right? All right, so this says find the domain and the range of each function. All right, so let's just do these together here. All right, so Ricky, what's the domain of this first problem here? So this function is a set of ordered pairs.
-2, -1, 0.
Yes. So if they're ordered pairs, then the domain is just assumed to be just the x values. Okay. All right, and Naomi, what would be the range?
From 0 to 5. Would I write that with like parentheses and then a comma, or what?
No, because it's actually just those 3 points.
Oh.
So it's not assumed to be everything in between. So it's just 0, 3, and 5.
Okay, thanks.
So you'd say the range is just 0, 3, and 5. Those 3 points. Okay? Because we don't know that it's a line or that everything is connected in between. Okay? All right, so now the next one. Its domain. Raylene. What's the domain of this polynomial function?
She's not here.
Oh, sorry. Jocelyn. Was Jocelyn there?
Yeah.
Okay, there she is. Okay, so Jocelyn, what would be the domain of this polynomial function?
So since the domain is just the x's, would it be negative 2x squared and negative 10x, or would it just be negative 10x?
Well, the domain is like what we are allowed to plug in for x. So up here we just have specific x values. But here you can actually plug in anything for x. You could plug in a negative, you could plug in zeros, you could plug in fractions. So the domain is going to be all real numbers. Now, I've got here the range is everything less than or equal to 1,512.49. So how could you get that? How could you figure out the range is that? Well, the easiest way to do it is look at the graph. And so if the graph, remember the graph, the range is the y values. So whatever the vertex is, the y value up here, it's everything below that. And so you graph it and then find the vertex. Find the maximum point right up there. Okay, we'll talk a little bit more about that. But just so you know that because the range can be a little tricky, that sometimes I'll just say, just use the graph to figure out the range. But otherwise, the other times you'll see in a minute, you'll be able to just look at it and tell. Okay. So, values that must be excluded from the domain. So this is just another way of me saying the same thing I said or put earlier. So, no zeros in the denominator. You can't have that. And you can't have negatives underneath the radical. If it's like square root, fourth root, whatever, even index. All right? So let's look at this one. For the first one, what number would we exclude from the domain there? All right, Jocelyn again. So what number could we not plug in for x in this first one? So Jocelyn, what value for x would make this denominator go to 0?
Positive 6.
6. So then the domain would be all real numbers except 6. Okay. Now, to get the range, you'd probably want to graph this. But if you look, the range here, the y values go from negative infinity up to 0, and then 0 up to infinity. But not the actual, it's never actually equal to 0. And so based on the graph, the range is all real numbers except 0. All right, now here, so you have, let's say you're using the formula to find the area of a square. So what's the domain? What numbers can you plug in for S?
Any of
Is
them?
that 1 over 0? Is that what you're saying?
Any of them except what values wouldn't it make sense to plug in for S?
0.
Negative?
Okay, zeros or negatives. Okay, so you're both right because it doesn't make sense. It doesn't make sense to find the area of a square with negative sides. So or 0. So we would say then that the domain is all the positive reals. And so the way you write that is with the script R with a little plus. You could also say X is greater than or equal to 0. And then the range, the actual area is also going to be positive reals, or you could say Y is greater than 0. All right, I guess we should use the same variables here. So let's actually, I'm going to change this to S into A. So the domain would be all the S's have to be greater than 0, and the range, the A's have to be greater than 0. Okay. All right, now this the last one here on this. Let's look at its domain. All right, so Naomi, I don't know if you can remember how the graph of this looks. Okay, but you could think of it the graph, or you could think of what are the values for X that you could plug in to not get a negative. Now you can get a 0, but not a negative underneath this radical.
So that'd be X would be anything bigger than or equal to 4?
Yes. Okay. So so you would say whatever's under the radical has to be greater than or equal to 0. And so then X has to be greater than or equal to 4. So exactly what you said. Now, if you remember when we talked about graphing, how this is the square root function, the car hood, and it's shifted to the right 4. Well, then that helps you know that the X values are from 4 on. So from 4 to infinity. The other thing that the graph helps you with is the range, because the Y values start at 0 and go up. And so the range is going to be the Y's are greater than or equal to 0. Okay. All right. Any questions on that? Okay, so just like what we've been talking about, for some functions it may be easier to find the domain and the range by its graph. And so underneath the domain I put X because you're looking at the X values of the graph. And for the range you're looking at the Y values of the graph. All right. So it says use a graphing utility to find the domain and the range of the function. Now, if you know what this graph looks like, you might could do this in your head without using the calculator. But if you don't know what the graph looks like, then put it in your calculator. All right, so Jocelyn, when you've got the domain.
everything greater than 16?
It sure is. Or equal to. Because you can't have the square root of 0. Okay? So x is greater than or equal to 16. So it starts at 16 and goes off to the right. All right. And Anna, what is the range?
She's not here.
Oh, she's not here. Dang it. I knew that. I'm really bad at remembering that. Okay. Golly, we're picking on all the people. All right, Naomi, I know you're here. What's the range?
Is it y is greater than or equal to 0?
It sure is. Okay. And so you could write that as y is greater than or equal to 0, the fancy r plus, or you could say from 0 to infinity. Okay. And it does include 0, so that's why it's a bracket. Okay. All right. Any questions on that?
Yes.
Who's your
How
mom?
do you put that into the calculator? Because I got a different.
Oh, okay. Okay. Let's do that. All right. So you have y equals, and then it's the square root. So the square root is second x squared. So the square root of x minus 16. And you don't see anything because I'm on the standard viewing window. Okay. So then you're gonna have to monkey with the window till you see it. So you could try, like, let's see if Zoom fit. Oops. Oops. So let's see. So then if I change the x's to go from like negative, if I know, okay, it's shifted 16 units, but let's say I don't know which way, okay, then you could have the x's go from negative 20 to positive 20. And then press graph. And oh, I've got it shading above, but that's okay. Let's get rid of the shading. Oh, I don't care what the color is. And so then there you can see it. So the x values start at 16 and go to infinity. The y values start at 0 and go to infinity. Okay. All right. Any other questions on that? Or anything from 3.1? All right. Well, let's go ahead and start in on 3.2. Okay, so the next section is on linear and quadratic functions. So we talked about functions in general in 3.1, and now we're focusing just on lines and parabolas, basically. So lines and parabolas, and then maximization and minimization of problems. These are actually, in a lot of calculus teachers kind of feel like these are the most important problems in all of calculus, at least calculus 1. So this is going to be a good intro into that. All right, so part 1, linear functions and their graphs. A linear function is any function that can be written in the form f of x equals mx plus b. So we had y equals mx plus b in chapter 2. Either way, m is the slope and the b is the y-intercept. And then, so if you could also have f of x equals a constant, like y equals 3, or f of x equals a 3, in which case the slope is 0. So these are all linear. All right, let's see if I've got control of the board now. No? Okay. All right, so as far as graphing linear functions, we did graphing lines in chapter 2. So it's really just the same idea. So if I have f of x equals 3x plus 5, I graph the y-intercept first at 5, and then the slope is 3. Now, with the slope, if it's positive, it goes off the screen. So instead of up 3 and over 1, just go down 3 and left 1. That's the same thing, so you get the same line. F of x equals negative 2, that's the same as y equals negative 2, so that's just a horizontal line through negative 2. Okay? All right, so go ahead and do the graphs for practice 1, please. All right, so the first one, f of x equals 3x plus 2. Go ahead and graph that in the air for me. All right, and how about the second one, g of x equals 3? Okay, good. So here's the first one, and then the second one. Okay. Any questions? All right, good. All right, quadratic functions and their graphs. A quadratic function is a polynomial function of degree 2. It is any function that can be written in the form f of x equals ax squared plus bx plus c. So the most basic quadratic function, what we call the parent graph, is f of x equals x squared. And so it's a parabola, and it has its vertex is at the origin and then goes up like that. So that's kind of the most basic parabola. So the graph of a quadratic function is a special U-shaped curve called a parabola. If the leading coefficient of a quadratic function is positive, the graph of the function opens up and the vertex of the parabola is the minimum point on the graph. So that would be the minimum. If the leading coefficient of a quadratic function is negative, the graph of the function opens down, and the vertex of the parabola is the maximum point on the graph. Okay? So it seems kind of weird, but if you're asked to find the maximum or minimum of the function, you do the same thing. You find the vertex. Every parabola is symmetric with respect to its axis. And so this is like the axis here of symmetry. It divides the parabola in two halves. So when you're graphing, one side should be symmetric to the other. So this is just a little tip and with the graphing. Okay. Now, all right, this y equals a times x minus h squared plus k, that's what's called the vertex form. Okay? And let's see, do I have a... Well, I guess we'll fill in the blanks after example. Okay. All right. So this is just a little preview here, I guess. So if the number in front, the a, that tells you how wide or narrow the parabola is. And if its absolute value is greater than 1, then it gets narrower than y equals x squared. If its absolute value is less than 1, it's wider. And if it's equal to 1, it has the same width. Okay? So that A in front, that's what it controls the aperture or opening of the parabola. So in this one, if we're kind of analyzing this, then the vertex is at the point HK. And so here, this would be 4, 3 would be the vertex. It opens down because of the negative, and the 2 makes it narrower. Okay? So your vertex is at 4, 3. You have it open down, and then it's a little narrower in shape. Okay? So if we look at this example here, okay, so what does the negative cause to happen to the parabola? That's right, it opens down. And what does the 1/2 cause to happen?
Makes it wider.
Makes it wider. And then the x minus 3. Well, let's just say this. What's the vertex here?
It's gonna be the
3, 4.
3, 4. So the 3 moves it shifts it to the right 3 and then up 4. So it's going to be over 3 and up 4. So the x minus 3 shifts the vertex to the right 3, and then up 4 is from the plus 4 at the end. Now the squared, that makes it a parabola. If we took out the squared, the exponent, then it would just be a line. So it's that little 2 up there that causes the whole thing to become a parabola. Okay? So the standard form or vertex form of a quadratic function is f of x equals a times x minus h squared plus k. To write a quadratic function in standard vertex form, then the first thing you've got to do is find the vertex. So sometimes you have to complete the square to put it in vertex form. Sometimes another way that you can do it is negative b over 2a, find the vertex. Another way that you can find the vertex is with the calculator. So in order to write the quadratic function in vertex form, you need to find the vertex. So these are the three ways. Complete the square, negative b over 2a, or the calculator. All right, so I don't think we're going to be able to get through the next example. So let's just stop right there, and we'll pick it up on Thursday with example 2b. So you guys have a great day. I hope we don't have any Moodle issues tomorrow. Cross your fingers. Anyway, good luck, and we'll see you later.